rules for the inference rules yet?
Yes.
Okay, so you understand there's like 25 different inference rules related to NAL 7-ish. I say 25-ish. Right. Okay. So that's kind of what you're testing.
I have a tenuous grasp. Yeah, exactly.
Right. Fine.
I'm recording this as well, so like I'll just go over it if I don't understand anything.
Okay. I can hear Patrick fine. Jared, you sound like you're in a fish tank.
Oh, really?
Underwater. Actually, underwater.
A fish tank underwater. That doesn't.
Oh, actually, it's better now. It seems to have cleared itself.
All right. I don't know what happened.
Okay, it's good.
Haven't changed anything. Fine. But yeah, it probably is a bit over my head. I'm not gonna. If it's just too much, then forget about it. But I'd definitely like to talk about the testing stuff at least, because that's something that I can definitely do.
Oh, I'm sure you'll get it. Suite. It's just knowing where to start. That was any question mark.
Okay.
Okay. Hey.
Hey.
Let's start with the test cases. The test system allows to enter certain beliefs and then to check a truth value of a certain statement with additional must believe statement, and this must believe statement also allows for certain tolerance. So you can specify minimum and maximum confidence, and also the same for occurrence time. So that captures all the things which are needed to test whether a certain belief is created by the system in a certain time.
Okay, there's quite a lot in there, Patrick. Can we just check Jared's understanding at this point? Mm-hmm. Did you get all of that, Jared? Hello?
Oh,
we lost Jared. Oh no. I'm glad we stopped.
Yeah.
Oh, you're there, right.
I did disappear for a second.
Okay, so do you understand all of that?
I got most of that, yeah.
Okay, great.
And the same exists also for GORS. And yes, this gives the system a bit of flexibility. So I think here I have some multi-step examples. No. Currently we are not using this tolerance feature, but in principle it allows it. Right here. Minimum frequency, maximum frequency, confidence minimum, confidence maximum. So it allows to check this. Okay. One issue with these things is that it's difficult to decide for a certain tolerance, because how should I say? Because the control mechanism works in a non-deterministic manner. This means that even a slightly different ordering of the input, for example, can lead to a different result. Most times, if you give the system enough time and it's not much input, then it will approximately be the same truth value which it converges to. But for multi-step inference, it's always tricky to check whether the truth calculations are correct or not. And
okay, sorry, there's something new for me there. I thought this test system bypassed the control.
This is true. This is true to some extent. There are two null instances running. So, for example, so let's, for example, test this one, null 2 test, and one of these null tests runs in a multi-step manner, and the other one in a single step. And the single step now bypasses control, while the multi-step
does not. Obviously, yeah, makes sense.
Yes. And yes, so one can choose whether there should be a multi-step or a single step now. The next thing is, I think we haven't converted the multi-step examples to test cases yet, but this is, for example, something we surely should do, because currently the multi-step examples are still in text form, like this one. So there is no automatic test case for them yet.
So I was getting confused about that last night when I was looking through it. But okay, right.
Right. I have several multi-step examples here, but I didn't add them by default yet. Maybe I should. And
that's in Pathom9.java.
Alright, Pathom9 test.
Yeah.
So. Where's the second? Here. Oops. For example, this test case is already a multi-step test case. And what's special here? Here I only checked if the system applies certain anticipations, and this one is not consistent already. There is our own test string in anticipate, and this test string gets bigger whenever the system creates an anticipation. So the test in this case is just a string equals of the test string in the anticipation and the expected anticipation. So this one needs to be extended maybe so that I could write, for example, tester that must anticipate cycles, then the content, for example, switch 0 on with a certain occurrence time range, for example. But this I didn't implement yet. This is why it's still done with this test string in anticipate.
Right.
Yes, from this perspective, the test system already supports most of the relevant things. It's, for example, also possible to attach an operator to the tester instance and, for example, test whether the operation gets called. And this is also currently a bit inconsistent. In order to test for operations, one has to attach an operator to the nav. A custom operator. I can show how to do this. Example. Let's use this one. Cycles is the maximum time the test should run. For example, if this one is 1000, then it stops after 1000 cycles. And if this belief is not formed after 1000 cycles, then it fails. Okay, attaching an operator. Right, this. So with now on exec. Not success. Right, this one should already work. What? For some reason it's missing some things. Okay, this one got defined already. think this should be everything which is needed. And now it should already run. Operator core did not happen. Because we didn't give it time. Right. This tester didn't work. In this case, because we are not using this must believe thing, it might be better to use directly on our instance. Oh. Right, passes. So this test now just tests up this if this operator is called. So I could enter, for example, different statements and enter GOR and check whether it executes a certain operator.
Cool.
Yes, and this is nearly everything which what the test system is able to do.
Right. It seems quite flexible.
Mm-hmm. Yes.
In some of the other examples, there was the like I noticed in the, let's say, in the text documents and in this not this particular example, but there's always like run the instant for X number of cycles, and then check whether its output has whatever. If that's really like a good way to do it, or if it's better to have like a max cycles like you have, give it an input and have some kind of event system or callback when the NAS instance generates the expected output. The reason instead of waiting X amount of cycles, because it might do it, like say if you're waiting 20, it might do it in 3 or 5 or something, right? It's going to change regardless. So I was wondering if that might be a better approach or not. And if it's not, why wouldn't it be?
I agree. It's the better approach. This statement, this tester, this is where there's a extra instance for it, extra class. I mean, this test now is doing exactly what you described. It's only using this as a maximum parameter. So when this derivation is derived before, then it won't wait that long.
That's perfect. Yeah, that's good.
Right.
Cool.
But
so
it
okay. Sorry.
But it misses some functions like must anticipate, must execute.
Right. Okay. So in terms of developing out more like a systematic testing suite, like I mean, it sounds like a lot of the groundwork already exists in OpenNAS for it. What were you imagining or what would be some new features or requirements that are missing at the moment, apart from what you just said, like must anticipate? And
Oh, I can show you.
yeah, please.
Let's see. What I really would like would be a generalization of temporal inference multi-step examples. I will show you why. This is an example which just fits into a certain sequence of events, a certain amount of time, and then I check the concepts. I check different concepts where I expect that those can be derived from the given experience. And what I do then is check the priority of this concept. And the problem here, let's say I add, for example, another event. Now I have to go here and add the relevant concepts like C, C, D, D.
I can already see that's tedious.
Yeah, you only just getting started as well.
Exactly.
And then I have to get the priority from this D. And this was already a bit of work just to get one possible concept. Oops, here it is. And what I really would want is to just define the sequence you want to put in, and then automatically get all concepts back which are relevant for temporal inference, or which are relevant temporal inference results. And
so how do you imagine defining the general concepts that need to be found?
You
They
need an
come
expert
from
system. The only way to do that is you have to have an expert
All right,
system.
guys, we need NAS to do this. No.
Well, no, it doesn't need to be an AGI, but it does need to be an expert system. So
Right.
it's a lot of rules, basically. It has to be able to read the input statements, figure out which rules apply, and then create sample output for those rules for the test. So it's a big challenge. It's not AI complete problem, but it's quite a big rule engine.
Mm-hmm.
I feel like the logic engine, like a REIT-based algorithm, would be able to return all relevant matches to that quite easily.
Well, it's not just matches, because it's a generative process as well. So there's forward inference involved in this as well. So forward chaining involved as well. That's the other problem. So it is an expert system, because you have to have forward chaining to determine what the outcomes of the inference rules are going to be. But then you're actually kind of writing, you need the inference rules to be correct for the chaining system to work. But what you're doing here is writing tests to test that the inference rules are correct.
Mm-hmm.
So it's
Sounds
kind
a little
of
cyclical.
Exactly. So it's a bit of a chicken and egg problem.
And in this case, also the priorities of the related concepts are shown, so that when there is missing one, where is it? So this one is just returning 0 if the concept is null. so that I don't get an null pointer exception. So if I run this one and set a debugger here, debug breakpoint, I mean, what? No, it works.
I mean, like you could still, like if you just define the concept systems that you're expecting, like you could totally, getting the priorities and all of that extra sort of code at the end of that block would be easy to get automatically. Like there's no need to be doing each one of those individually, right?
I agree. But this is true. Oh, I could just define a list of strings, and I agree. This would already help a bit. But what would be nice? But
it would be nice if we had it.
Right, if this would come automatically from the events.
Right.
So this test system would then maybe already use some inference itself to derive what it has to check for. One thing is possible, because at least in this test, I'm mainly interested in the priority of the related concept. It would be possible. Oh, this we can try. It would be possible to attach an on-derived event to the now and put all of the derivations into a string array list, and then just going through the list and calling now.concept to get the concept and priority save to get the priority. This we can try. This is done very fastly.
That's only going to give you what the system produces. But if what the system produces is wrong, then that isn't going to be very useful.
I agree. It's only good for this case where the priorities are of interest. So this is more a budget system test. how it deals with a lot of events.
Yeah, I think the issue here is that. Sorry, I keep clicking the screen there. I think the issue is that if you try and automate the generation of tests, then you then have to test the test automation process to make sure that's correct.
Totals all the way down.
Exactly. So I don't know if there is an easy way of actually removing the manual aspect, because at the end of the day, you're the only ones that know what you expect to get out of this. So I mean, you can maybe simplify it to a degree, like the priorities, but I think ultimately there isn't really a shortcut in testing and sort of generating the test cases, because whatever you use to generate them, you then have to test. And as I say, we've got the same problem again.
Agreed.
This is true. But at least for the budget system test, it would work.
Yeah. That does look very tedious.
All right, we can try this.
The now 7 test cases.
Sure.
Okay.
But that was the subterfuge I was got onto this call about.
For example, it's possible to define a occurrence time where the derived event should occur, and so there's the possibility to check for the time additionally.
Okay, can I ask some high level questions before we get into the detail?
Go for it.
How do you map the meta rules to the testing process to make sure you've got full coverage?
Oh, this is a real issue. What would be
Sorry to have to start with a real issue question.
What would be really nice would be if the rules would have some sort of reference, like let's use a good example, like this one.
Yeah, to be honest, I've actually done that, Patrick. I've added numbers to all of mine so I can refer to them.
This would be nice because it would be great if then the Java code could, for example, say with an additional annotation.
Yeah.
Still one.
Just some attribute or something. Yes.
Right, and the test now would then know that or it has to load is this inference or, which would make testing a lot easier. And additionally, what would be even greater would be to see then whether this one is used in an annotation or not.
Yes.
This would be great.
Okay, so it's a problem at the moment. Fine. Fair enough.
Right. Or if I know by intuition which roles correspond to what, it would be a lot better if this would be made explicit.
Right.
Another possibility I also thought about was to use the inference rules itself as their own test cases. For example, to specify a meta information for example, so that everything, that each rule has additional proof value information below it, and everything, and then the test case would be automatically generated. It would go through all the inference rules. For example, it now is at this rule, then check for the test meta information. Then
okay, that assumes a default input value, presumably.
All right, it would just input this one and this one. And
yeah, but it's going to have to assume a default truth value and a desired value, yeah?
All right, this one is the truth value.
Oh, sorry, that's just the truth value. Sorry, not the desired value. Yeah. Sorry, yeah, I'm with you. Got you. Sorry, yeah. Right.
And it would also be possible to define multiple of those.
Yeah, so then that would be the desired value, right? Okay.
Right. And maybe to distinguish between desired value, maybe something like this for desire. But this was just an idea.
Yeah, it's an idea. It's kind of pluses and minuses. I think I like the idea that you've got the test data incorporated within the meta rules. I dislike the idea that you're messing up the very nice meta rule file with all this test data.
I agree. There's one possibility. Let's try this.
Well, you could do the same thing you did a minute ago, which was you can name each rule, then have another file with that name, but test data for that file for that name. So like
this one.
SIL1 meta rule, SIL1 test data, and then they'll link together.
This is nice. I think this is the best solution to have an extra file.
Okay.
This we can also draw. Right, because this is really a bit an issue that there is no test data directly linked. So I don't know
Yeah.
which rules are tested and which ones are not.
Okay, and the other question I have then is, how can you ensure that the result you're getting from a test actually ran the rule you thought it did? Is there only one possibility, which I doubt, to give you the result that you got, or is there some other mechanism that ensures that you're using the right rule? You understand? You understand the question?
Okay. Currently, there is no. Currently, it just checks for the. So it applies OR rules and looks if the expected truth value is.
Okay, so it's down to the design of the test case to capture the uniqueness of the rule explicitly. Although it's kind of a bit of hit and miss, because some rules I think could actually apply themselves to several different data sets. Sorry, the same data set could apply to several rules and give you answers. It may or may not be what you're looking for. Yeah. Okay, so that's another challenge. All right.
Right, and what would be great?
That's a very good point.
When we really would have this one with an additional file still one, then it would
resolve
that problem.
Right,
you would want that you would want that derivation to have the label of the inference rule that created it, right?
Right.
Yeah.
Do you not do that in the actual? Do you not capture which rule created the derivation in the stamp?
This one we already capture.
Yeah, I thought you did. So you could actually you could check that once you have an answer. You could confirm it was the same rule that you wanted it to be. Yeah. Okay. So that can be done, right?
That would solve your problem, right? Well, the issue that you raised, Tony.
Yes. Yes.
Right. But also, for example, if this label is here, it best would be that it only loads this row. Then it doesn't.
That would be better. Yeah.
Right.
Yeah, I agree. That's a better approach.
Because then also resolved. Yes. Where should we continue?
Do you actually want to run through some of the rules, Jared, just to see some in action? I mean, not
I would
executing.
love that.
Okay. So can we pick some from
to run through it?
Yeah, from the meta rule file. Let's just start at the top and then do a few and see how the tests are implemented for them. But can we do a NEL 7 one?
So, for example, this is an L7 row, is an L5 row, but which also works with dense. And you see this by looking at this meta information, which basically says it works for all orders, which means this row also stands for this row. And also for the other cases. So oops. So instead of writing this one, it would also be possible to write this one. But this one is more elegant, which just says this row works for all orders. And but sometimes in the testing phase, sometimes it was needed for me to write it this way, because there's a special feature. Let's comment this one out. I can, for example, say that the system should start up only with this inference row. So when I start the NAS now, then it will just be able to do this inference. Let's copy the premises. And the result can be obtained. So there is also a way to test a single roar.
Okay.
Manually. So this NAS would now not be able to do other inference. For example, if I enter this, it's not able to derive anything from these two statements.
That's kind of neat.
It's also interesting how the priorities go to 0.
So Jared, do you understand what the ForSang's doing now?
Yeah.
Good.
The next thing is derive allow backward, and this one is important because different than in the old NAS system, we don't state backward inference rules explicitly anymore. Instead, they are derived from the forward inference rules. For example, if this is an inference rule which has this allow backward statement, this allow backward statement, then.
Well, there's actually a rule in the meta file, isn't there? I know it's not used, but the backward inference rule is in there, probably commented out at the moment. So it's there for reference if you need it.
Oh yes, right.
Okay, great.
So, I agree. Should be stated somewhere.
Yeah, down near the bottom somewhere.
Oh, here.
There it is. Yeah.
So this one shows a meta derivation how from a given row two new rows can be derived, which are only for questions. Right. And there are some special cases where which really only apply for questions, but I'm not sure if this one is needed. No, I think this one is redundant because this one is can also be derived by the syllogistic forward rules.
Only no, but this is if it's already a question, isn't it? Is that right? Let's have a look. Oh, it's no, but this is a backwards. Hang on a second. Oh no, you're right. Yeah, yes, it is covered.
Because this one,
yeah,
does derive questions from.
Yeah, exactly. Yeah.
And there's another ORDAP which is backward inference driven forward inference, and this one is for some is only for how should I say, to direct forward inference into a certain direction, like how should I explain this?
Wait, what? Backward inference driven forward inference.
Right. To be honest, I think that in the end these rules will not be necessary. but it was in the old OpenNAS, so I thought I will add them.
There's some better examples in the NAL 4 stuff, or composition on both sides of a statement. Now that's that's more relevant.
Okay.
I agree, because if this one would be a judgment and this one would be a judgment, the system would not derive this. But if this is a question and this is a judgment, then it derives this. So it's a possibility to allow certain derivations only to happen if there is a question which demands it. Make sense?
I see. Yeah.
But I think that in the end, these rules won't be necessary. But
well, they're definitely necessary now, so please don't take them out.
So why won't they be necessary?
Because yeah, if these ones are, if instead of only allowing them for question tasks, if instead of this they would be allowed generally for forward inference, like now, then the same result can be derived.
No, you don't want to do that. You're gonna have arbitrary products everywhere.
I agree.
That's the problem.
It's a counter issue.
I mean, I think it's an interesting point, Jared, actually. In an ideal world, you wouldn't need to do it this way. But at the moment, what happens is you only get derived products like this on both sides of a statement if a question asks for it. If you allow general inference to do that, it's such an easy thing to do that products would be absolutely everywhere. There'd be so many products you wouldn't be able to move for them. They'd be just in every corner swamping you. There'd be nothing to stop them forming because they can form pretty much from anything. You only need, as long as you've got one product, then you can make another one, and you can make another one, etc. So it'd be kind of just a explosion of product, which is why we do it this way at the moment.
Gotcha. I see. That's quite a pickle.
Yeah.
And if you look at the old OpenNAS code, and what one observes is that there's a lot of effort just to make sure that certain derivations only happen in specific cases. That there's a lot of effort because I think if the inference rules are used wisely by the system, then how should I say? Then the control issue will be a lot easier. So the system doesn't run that easily into combinatorial explosion. So it's a difficult.
This is difficult. Quite new to me. So there is certain restrictions on the inference itself.
Right. So it's not a general null reasoner, like many people think that NAS is, but there are certain valid derivations of null which NAS will not make.
Is that I mean, apart from in the code, is that documented anywhere, or is it one?
No, it's not.
I got my.
It's a very subtle. It's a very subtle understanding. Yeah.
I will try to put a bit of it into the paper which I read.
Right. Okay. How do I find all of these specific? I mean, they're not all in this rule file, right?
Yeah, they are. Yeah, they are. Yeah.
Oh, okay. Okay, good.
Right.
Yeah.
As long as they're in one place.
Yeah. The logic is designed to be. So there's no redundancy in it, basically. And Pei is very, very careful and very protective about adding any rules in that will create a degree of redundancy. So there is generally never two ways of using a rule to get to the same. Sorry, there's no way of using two different rules. Actually, I how to explain this without. Yeah, it's kind of tricky to explain it as well. I mean, Patrick kind of captured what the key here is. The idea is to take as much pressure off the control system as possible. So the logic only allows sensible combinations of rules or sensible combinations of premises to create new premises.
Right.
And it does it in a way that it's also so there's no redundancy in the rules. So there aren't lots of ways of creating the same thing. You might end up with the same premise, but because of different reasons.
Right. Right.
And at first I thought that I probably won't include most of the things, but then I saw that with the rule engine it's very easy to specify things like this backward inference driven forward rule.
The key message is don't just start adding rules into this file because it will screw your control system up.
This is true. And
it's very delicate.
In one thing where you see this nicely, let's say you want to capture the essence of conjunction, and you would just write this. General conjunction rule. You won't find this rule in this rule file, because if this one would be allowed, it would mean that for each two tasks, for each two judgment tasks in the system, one could derive a conjunction between them. For example, conjunctions like my laptop is black and my car is green. Things which are semantically not related. Well, different statements like my car is fast and black are semantically connected, and the inference rules in this file only allow derivations where there is a semantic connection. This is why I didn't add rules like this one, because it would blow up the memory.
Yeah. Cool. Thanks for outlining that.
I think a way to think of it is that the inference rules themselves are designed in such a way that they are a chaining process. So premises are chained via the inference rules.
Right.
I forward or backwards. So you can only create valid chains because the rules themselves are valid.
Yeah.
So therefore everything has a semantic meaning, and that semantic relevance is maintained because of the integrity of the rules. If you start playing with the rules and changing them and tweaking them and putting things in when you're not understanding what's going on, you will end up with semantics being broken and meaningless statements flying around the system.
That sounds not fun.
No. So do you actually grasp that?
Yeah, I do.
The issue of that. Okay, fine.
Yeah.
And it's, for example, if I say a sentence like, tomorrow I go to the school and I was swimming in the pond. This is totally a semantic gap. This sentence doesn't make any sense. And similar, we don't want conclusions which have such a semantic gap.
Right.
Did my sentence illustrate what I mean?
Yes, because it made no sense. Yep.
Yeah, and it's a really critical point of NAS, because one of the things that NAS does that machine learning systems don't do is it can generate a large number of valid inference, semantically meaningful premises from a small number of samples. It doesn't need a huge amount of data, but from that it can generate a very, very large set of semantically meaningful premises and relations, because of the nature of the inference rules. They enforce that restriction, so they are carefully designed. They're not just inference rules; they're semantically preserving inference rules, which is kind of a different thing.
Yeah. No, I wasn't aware of this, but it's definitely good to know.
It's kind of the key thing about NAS. It's like it's its biggest point. That's its secret sauce, if you like.
And also to show this in the older version, because there we had a better memory viewer. Let's say, for example, I will just use the simple representation of normally. So, for example, with this, you directly see that that those both statements are only connected through cat, and also the inference won't combine arbitrary. It won't let arbitrary concepts in memory do inference with each other. Instead, only these which have a semantic relationship. And this is very important, and this is why rules like AB, like this one, cannot be allowed in general.
Right.
So the only exception to that is temporal induction, which is obviously a NAL 7 related rule. And there's strong constraints on what is allowed. You saw some of those yesterday when we were going through the perception workshop, that as an example. So I mean, yeah. So do you want to carry on with some more of the NAL 7 rules?
Yeah.
Is that actually hitting what you need here, Jared? Because it was your request, really.
Yeah, I'm learning a lot. Yeah, thanks.
There's just one thing I wanted to add. Like Donny said, time is an exception to this, and I personally try to see the temporal aspect as a special case of a semantic relationship, and in this case, then it's more, how should I say, it fits into the philosophy of the system nicely, because if you see it as a special case of a semantic relationship, that they are temporally related.
Right, so the time
that's a good way of looking at it.
Yeah.
Right. So then let's go through the war file.
Let's do it. Let's do the deep dive.
So I think that started off, just so we're clear, so that there is a set of NAL 7 rules in here, but also it becomes clear that several other sections, while not specifically NAL 7, if they have the metadata of same for all, then that will apply to NAL 7. Sorry, order for all same, then that will apply to NAL 7 as well, because that expands out to all the temporal rules as well.
Right.
And right, so you can just search for this one and you will find all of the temporal ones. And there are some rules like let's see, like this one, where order for or same does not work because part of this is a valid inference. It doesn't work for all orders, like this specific. When and when after BS happens, then it's usually the case that B and S are temporally equivalent in the sense that after this one this happens and before this one this one happens. So this is an example of an inference rule which only works for this combination of temporal order. This is why this is why in this example the order is also specified by the rule explicitly. And I think it might not be necessary. Or these special rules which are for specific orders, the result of these rules can also come through through multiple application of other rules. At least I didn't. I really went through a lot of this to see how it can happen otherwise, and I saw that it's really. I didn't find a single example where the result of such an exceptional rule would not be able to be derived from other rules which don't need this special order handling. So this is a good thing because in the end it might be that we can kick them out.
Right.
But I was very careful, so I thought, let's let them in so far.
Yeah.
And maybe I can add a little context here as well for you, Jared. I've been working on NAS for about 15 years now, so a long time, and I've seen a lot of long before it was open source, and I've seen a lot of change in the publications and then the open source code, and various things have happened. When Patrick built this meta rule language and this meta rule file, I told him, I said, this is without any exception or any doubt at all in my mind, this is the single most important contribution that has ever been made to the NAS project. So I cannot underestimate how important this meta rule file is.
Yeah, right.
Thank you.
If you tried to understand these rules before, well, you never would have done. Basically, you never would have understood them.
Well, I came into NAS like a few years back, but then I just kind of lost the plot because I found it quite difficult.
Yeah,
it's a lot easier.
I remembered your name.
Oh, yeah?
I thought it was you. Yeah.
Yeah. But yeah, no, this is definitely a lot better. Definitely a lot better.
And I remember where you, Jared, created some rule file for, I don't know which, if this was a custom syntax, but this one was the inspiration for this. I remember because you suggested that we should use a declarative way how to specify them.
Yeah, exactly.
In the beginning, from where I saw this, it never left my mind.
Happy to plant seeds. Happy to plant seeds.
Mm-hmm.
Oh, it's awesome. It's amazing work, guys. Should we look at the? I mean, is there more that's more context around this around these rules, or can we look at the now 7 tests so far and what needs to happen there?
Yes, we can switch to the tests. Just one thing I want to add. This rule file, sometimes the rules look quite arbitrary, but if you really look into them, what they are saying, that for example this happens, that before this one, that this one happens.
Yeah, it has all those conditions that are required.
Before the other, and this one after this, and you see then you see that this rule actually makes totally sense.
Yeah,
really,
it absolutely does.
They are to some extent self-explaining why they are like they are.
It really does, yeah, absolutely.
Like this one is a nice example that when this one from this follows this and from this follows this again, then they must be equal by comparison.
Stuff is so clever.
Okay, let's switch to the test cases.
Yeah, okay.
I should add, by the way, you do need a genius programmer to convert that meta file into actually executable Java code. who's currently busy doing something else at the moment.
Yeah, what is Seth up to these days? Like, I know he's working hard on something, but
he's working on our own branch, but not on GitHub.
Just on Bitbucket or something, I heard. Yeah, okay.
And it's really, how should I say, it looks very promising. At first I thought that it will lead to nonsense because he wants to eliminate the segments, but he didn't eliminate it. In between understood why it's important and has in between simplified the raw file and made a lot of background assumptions of this inference file more explicit, and it looks really promising what he did.
Cool.
And
need to check it out.
When I have time, probably in summer, probably I will again branch from his work and see what I can. If I can create a working version based on it.
Alright. Do you have his repository URL? I'm guessing it's public, but
yes.
If you can paste it in the chat,
Should be.
I'd love to browse his work.
I will post it later. I'm not
Yeah. No rush.
Okay.
Plenty to do.
Yes, and it looks very promising what he did.
So,
one thing I want to add, for example, he added a meta rule for the order of statements, which means there is no inference rule in his work anymore, which specifies a special order. Instead, all the valid possible derivations are automatically derived, because it's really because it's easy to define a metaphor which works for arbitrary order of the premises. And this is very good that you added it. Okay, then let's go on with the test system.
All right.
What were we missing so far? Right, so it's possible to check for the occurrence time of the derived event. And this is everything which needs to be done by the NEL7 test cases. Else they just use the drop value check. Right. And what you see here, what's happening here? For example, if this one is a input and this one is an input, then it derives, it is expected that it derives this statement, and in this case it's a abduction because it's going in the opposite direction of the implication. And what it also checks for, because this one is entered in cycle 0 and the duration of the system is 5, that this one is correctly shifted into the past, because so that the occurrence time is really shifted correctly according to this interval.
I see.
Right.
Huh.
I have to say that wasn't a very convincing IC, Jared.
Yeah, well, I mean, like I understand that the occurrence time is shifted. I can see how it would be shifted back 60, but I don't understand why there's that extra -5.
That's what I thought.
Let me think. Let's draw it.
Okay, good. Got everyone thinking now.
Alright. Let's use this one.
I think
hope it's correct.
I think Patrick was an illustrator in a former life.
How is the example? Key hard room enter. So let's say
somewhere wrong with that statement, Patrick.
Sorry?
There's something wrong with that second statement.
Indeed.
Oh, that's better. Right, okay.
if this one happens on the time scale, and it is known that this one happens after the, let's just write this way. We said it's 60. Steps. But after, and whenever this is the case, that for example A happens after B, it means it's additionally plus duration. And why is this? Because if it would be smaller than plus duration, then it would be concurrent.
Right.
Does this make sense?
And duration is the system parameter duration.
Right. So
that's what you're fiddling around with today.
Do you understand how tensors get converted to occurrence time, Jared?
Not exactly. Like I just assumed it was some kind of difference between.
Okay, it's really simple. Yeah. It's really simple, right? If it's a present tense, occurrence time is whatever the time is at that moment in time. If it's a future tense, it's the current time plus the duration. And if it's the past tense, it's the current time minus the duration.
Right. Okay.
That's it. So when the tenses come into the system, they get converted to an occurrence time and then they disappear.
Right.
So everything in the system has an occurrence time, either present, future, or past.
Yeah. Okay.
So, for example, if this is our timeline, to show it even better, there's a durational window. When two events happen inside of this window, and
it's a train. It's a big train, isn't it? That's what it is.
This should be the durational window.
Playing charades now.
Right. So the system
so that's
says,
the window between A and B, the occurrence times. Yeah.
So
I get a concurrent.
So all of them did not occur in the same inference step because they occur in the same minimal duration window. Means they are observed as being concurrently occurring by the system.
I see.
And this one, for me, I always thought that this one is not necessary. That all we need is to measure the time between these events and as good as possible. But if we look at the inference rules, it's if you look at the perception of a single moment, then often it's not the sequence of the events which are important, but to observe everything which happens and is observed in that moment as happening at the same moment. How should I say? For example, in your brain, you have different sensors, and they all work with different speed, and somehow this has to be synchronized. That you see, for example, if you clap your hand, that the observation that you clap your hand and that you hear it is synchronized in such a way that you have the impression that both happens at the same time. This even works if someone stands, I think, 20 meters away from you. It's still that way. Out of the audio reaches you, I think, 100 milliseconds.
It's 80 milliseconds is the limit.
To measure it, but up to 80 milliseconds, the brain synchronizes it in such a way that it, for you, gives the impression that it happens at the same time. And suddenly, if this 80 millisecond interval is overrun, because, for example, the distance is a bit bigger, then suddenly you see that the clap of the hands and the sound signal does not reach you at the same time. But up to 80 milliseconds, the brain synchronizes it for you so that it looks for you.
I had no idea. That's really interesting.
That's very strange. And there's also some, if we look at NEL, there's really a certain structure in NEL which shows the benefits of this. Namely, there are many inference rules. Let's go up to the conjunction rules. There are many inference rules like this one, which when these ones would be events which were observed to be different in timing, then there is only one way for this rule to match. Because if this one is because they are different in timing, this would mean that this is a sequence. It would eliminate a lot of possible derivations. And so also in the NAS system, the parallel conjunction has certain benefits of when it comes to namely whenever the order does not matter.
How? So, sorry, can you, what?
I can show an example.
What's the benefits exactly?
The benefit is that a lot of conclusions which are otherwise missed can be derived.
Because of the fact that we use this duration window, things that are slightly different in temporal timing, because they're within the window, they can now all be considered the same.
They can be inferred. Gotcha. Yeah. Okay.
To be equivalent. Right. So now now you can generate all these conjunctions.
Yeah. Okay. Okay, that's clear.
But it was still a bit confusing. This is where I want to give an example. Let's say we have sensor channel 1. And sensor channel 2, which are not synchronized with each other. Let's say this one operates with a 15 millisecond cycle. And let's say this one operates with a 70 millisecond cycle. And this one, for example, says that the pixel 1 is on, and this one says that, for example, this is audio channel. Frequency 50 is on. So two different channels, which both, for example, generate such an event. This one every 50 milliseconds, this one every 70 milliseconds. What's happening now is that there are two possible scenarios. It could be that this event occurs first and this one second. But it could also be that this event occurs first and the other one second. The problem now is this only confuses the situation. Because everything the sensor channels would wanted to provide was the information about the current sound and the current pixel. And are seen as happening sequential and not in parallel, this situation would be observed differently than this one, although they essentially carried the same information. So this is my theory why it makes sense to have a duration window to make perception simpler. To allow sensory channels which are semantically unrelated, namely one is about about pixel data and the other one about sound, and they're operating at different cycle times and are not synchronized with each other. And although they are not synchronized with each other, such a durational window gives a very easy way how to synchronize them in the end. Namely, to skip the information whether this one happened before or this one happened before. So it gives the system the ability to see both scenarios as the same. With these two pixels, with these two informations now, it looks like if the overhead is not that big, because this is only double amount. So there's this situation and this situation. But if we have, for example, 50 or 100 of different channels, different events from different channels, then there are already thousands or millions of different possible orderings of these events. And we don't want the ordering of these events in a single moment to have an influence on how we observe this current moment.
Yes. Yeah. No, I can definitely see that.
That's a bit confusing, because so far I never summarized this, but it always was in my mind why this indeed makes sense. Often I thought we only need a sequential relation, but this example opened my eye with different sensory channels which generate different events and are not synchronized with each other. How to make sure that when the channels provide a certain information, that you don't observe it as differently just because the order of the incoming events was a bit differently, just because the channels were not synchronized. So this gives us a solution how to work with a lot of sensory channels and without needing to care about synchronizing them. And
Yeah.
Right. Right, and it's somehow it's also very plausible that the brain come up with such a solution. Because
do you guys know why that happens, like evolutionary speaking? It just seems bizarre, but I mean, I can totally understand the rationalization for it in NAS.
Yeah, no, I don't think there's an understanding of why it happened yet, although there is an interesting theory that it's actually a cause of schizophrenia when people are unable to, or when their durational window doesn't work properly, they're unable to allocate their own thinking to the same time frame as the rest of their mind, if you like. So it seems to be as it's a separate source, like someone else is talking to them.
Right.
There's a really nice YouTube video which we have to send you.
Yeah. Link it in the chat. I'd love to watch.
And where should we continue?
Please.
Where?
I'm learning so much.
Where would you like to go, Jared?
I guess okay. So I mean, I'm learning a lot about the special cases, not special cases of rules, but like the constraints on the rules. Learned a bit more about the occurrence times and the duration window. I guess I mean, I would like to make I didn't fully read your response yet, Tony, to my posts on the forum, you were saying there's like 3 categories of syntactic, semantic, and dynamic.
Oh yeah.
Basically groups of rule tests that we need to do. I was wondering what's in place for Now 7, what isn't in place, and what that would look like if it were. That's probably too big of a question. But
yeah, I understand. Yeah. You're trying to get to the bottom of Pay's comments about, there's some issues in there and we need to fix them, but we don't really know what they are yet.
Yeah. Is it just a silly
question?
Is it a question that has like moo as an answer at the moment, or?
It's an assumption, and I think it's a valid assumption that there are some things wrong in there. The question is, which things are wrong? We don't know yet. That's the problem. And we need to figure out what are the tests that will help us identify what is wrong.
Yeah.
Which is kind of hard to test for something you don't know what you're looking for.
Right. Okay, that's a lot more clearer. Okay, so it's just not even okay.
Yeah, it's based on the assumption that there's probably something wrong somewhere within the rule. They're not perfect yet. There's some issues with we just don't know what the issues are or how they manifest themselves yet, and we've got to write some tests to find them, even though we don't know what we're looking for.
But do we even know what we want?
That
is kind of the saving grace. We kind of know what we want.
Okay. So can we make some tests around what we want?
Well, that is ultimately what we do. The issue is it's trying to specify concretely a test that works. I mean, if we go to the 3 categories I gave you, right? Syntactic testing is easy, right? That's really straightforward. It's all that's testing is that basically we've put the characters in the right place and it produces simplistic results from simplistic inputs.
Right.
Semantic testing is more difficult because it means we have to test whether the results of inference are actually semantically correct, which is much more difficult.
Right.
And then there's the next one, which I guess is kind of a mix between what Pay calls multi-case testing or multi-step testing, and I call the dynamic testing. I think the multi-step testing is a subset of dynamic testing, but it's not all the dynamic testing.
Can you explain the differences between your term of dynamic testing and multi-case testing? Or multi-step testing?
I can explain it abstractly. The multi-step testing is
to like start off with a NAS instance. It's like isolated. You do a whole bunch of sanity checks on just the simple inference rules itself, and then like as Pei was saying, how over the age of the system you start introducing more information to it and seeing its ability to learn, and then you eventually get to the point where it is maxed out in concepts and it's processing multiple tasks, and then you want to test whether it can still handle the heat.
Yeah, although actually it doesn't take long to max it out on concepts. It's actually quite a quick process.
Yeah, I've seen.
Yeah, no, but I don't mean in a negative sense. I mean it will very rapidly generate enough concepts to fill its memory, all semantically meaningful, but not necessarily very relevant.
Right.
So it will quite quickly fill its memory because the rules generate quite a lot of semantic inferences. So, from a relatively small input set, it can generate a lot of valid inferences. So it does very rapidly fill up its memory. So it's not a problem populating a system, but we've done very, very little testing on fully populated systems, only on empty systems. And as Patrick was saying earlier today, he wants to explore what happens when we start lowering the durability value, because it's impractical to use a value of 0.8 for everything, because once you get to a real system, that's kind of reserved for more important stuff, or more durable stuff than everything. You don't want everything to be that. So we do need to look at how the system performs in a broader sense, but we don't really have any detailed views about what those tests are yet, other than we know we need something, and we need to start looking at that stuff. We don't know exactly what that means yet.
So, right, cool. Sorry, I was listening, but what was I going to say? Are you still there? Sorry, I think I might have cut out. Okay, cool.
Yeah.
So like, I guess, what am I trying to say? Like, is there something that's happening in Now 7 that's just completely broken at the moment in the implementation, or in the rules?
Not that we're aware of, no.
Okay, but it might exist, and there's no way to know at the moment because we don't. Okay, gotcha.
I don't think there's anything obviously broken anywhere.
Right.
There's some missing pieces, but there's not really any broken pieces that we know are broken. Because if they're broken, we fix them.
So yeah. So like, see, this is kind of my concern. It's like, obviously the implementation isn't finished yet, but it would be. It sounds like it's very, very hard. This is a very hard problem to solve, isn't it? Like you either build out the system and try and have it running, and then going, okay, why isn't it working? Or you can do these isolated tests, but at the same time, like apart from testing what the current existing assumptions are, it's not entirely very meaningful. Like,
it is a challenge. I know what you mean. It's kind of, at some point you have to make a decision to move on to the next stage, and I understand that. I think Pei is very conservative from that perspective. He's academic. He wants to be rigorous. I don't think we have not been rigorous yet in our testing. There's no question about that. We've been moderately diligent, but certainly not rigorous. So I think we need to find a way of being rigorous.
Yeah. So, I mean, that's that. The crux of all my questions is how can I be the most meaningfully contributable to the project? Granted, I want to be doing it on my own implementation because, well, I find Clojure easy to read.
Hey, look, we're all there. We're all doing the same thing.
Yeah.
I've got F#, you've got Clojure. Patrick's in Java, so we're all everywhere.
Yeah.
I think Square's using 4 different languages.
Yeah, so I guess I would really like to contribute. It sounds like I don't know if I can do anything in terms of creating anything. Like I couldn't create a test for Now 7 because I don't know how to test it beyond the current assumptions. But
I mean, okay. Look, in terms of contribution, I think it's useful to have certainly more than 2 reference sources. So I think having another reference platform is not a problem at all. I think using another language will bring a different dynamic to how you approach the problem. That may identify issues in a different direction. The same as because I've done it in a functional language, I've identified issues from another perspective as well. So, well, I guess closure is kind of function as well. So, it's the same sort of thing. So there is a difference from that. So that's useful in its own right. Just having these sessions, I think, going over things is useful as well, because it reinforces our own understanding. It makes us question some of our assumptions, which is always useful, because sometimes we've forgotten why we've done things, or an assumption might turn out to be wrong when we actually think about it. So that's valuable in its own right. So I don't think there's an issue about contribution specifically. If you feel there's something an area you want to add, I mean, take on an area that's new. I mean, by all means, go for Nel 9 or something. I mean,
I think, I mean, like the only modus sort of operandi I can really operate under is kind of just following the framework that Pei has laid out, and then referencing both of your implementations where I can. Obviously, like Tony, your control mechanism is a bit different, well, a lot different. But then and then I guess just creating I'll start going off into some deeper and darker areas, because why not?
Yeah, I mean, the one thing I would say, and I've made this mistake so many times I've lost count now, is actually moving ahead when you haven't got a solid foundation. Because it's completely counterproductive. You never know what's not working. And that's exactly the issue that we're trying to avoid now. I mean, we can go ahead and do Nel 9, but then if it doesn't work, we won't really know why. Because it might be something wrong with Nel 9, or it might be something wrong with Nel 8, or Nel 7, or the control system, or who knows. So that's the reason we're being cautious here, is because when we move on to the next level of experimental research, we won't know what the results are if we haven't got a known base to calibrate against.
Right.
I mean, that's the issue.
I totally agree with you, but at the same time, it's also like you said, it's very difficult to quantify.
Yeah, and I would say
each level.
I know you've only been working on this a little while, although you had some previous experience on it. I think there'll be quite a lot you'll find that you haven't realised as you try and do stuff. Now 7 is by far the most difficult level.
Patrick said that as well.
There's so many subtleties in it. I mean, Nel 8 is kind of dead simple in comparison. I mean, it's kind of almost one of the easiest,
Right.
Nel 9 conceptually is very, very basic. It's really just Nel 8. Really, there's no difference. They're just some operators, but the selection of those operators, that's the magic.
Right.
And that's a massive amount of research. What mental operators do you need to be able to think?
That's like, I mean, so like the Pei was talking about code versus data, and how in an adaptable system, like the data is going to be easier to transform or modify to adapt as opposed to the code.
Right.
And so part of me thinks like, okay, even if you don't have a lot of like everything perfectly in place, if you've got like now 1 to 6 kind of stable, then and you introduce now 9 and kind of work on that, maybe the system is capable of compensating for some of its deficiencies.
You can't add now 9 without 7 and 8.
Right, of course, but I mean, like, you can still have it in its current form. And I'm not saying it's not gonna be perfect or anything like that, but there might be. Maybe I'm just like no, I'm probably just, I don't know enough. I don't know enough to really say anything. So.
But I think from previous discussions, I think what you're saying is that there should be a way of adding some of the NAL 9 capability into the system as a control function. Is that right?
Yeah, like, I mean, it doesn't necessarily need to be like control, but I mean, like, you can give it, like, it sounds like you could still give it an urge to do like abbreviations, or you can give it an urge to shorten its own duration windows, and then maybe this is super wishful thinking of mine, but like I'd like to run it probably with a little bit more knowledge that I would figure out along the way, and kind of see if it's capable of well, it's basically just, instead of doing hard changes in the code, doing softer changes within NASES itself, and seeing if the system's capable of reasoning its way to some kind of compensation in its thinking. Does that make sense?
Yes.
Well, can you explain it to me? Sorry, I didn't quite understand that.
Basically, I'm kind of entrusting NAS's existing reasoning ability, even with a gimpy version of NAL 7, to be able to, because I mean, NAS is essentially trying to map its goals with its actions. It sounds like, in principle, it might be able to compensate for some of its deficiencies in the code. Not completely, but it might give some clues if the system is constantly making the same kinds of compensations over time.
No, I agree. It's kind of, if it can recognize them as patterns, it can work around them.
Right. And I understand that's probably wishful thinking, and obviously it might not necessarily work, but it's something that I'd like to try.
No, I understand the thinking that if there are flaws, it should be able to kind of work with that as part of what it is. The only thing that comes to mind in my head when I think of all these things is that it only takes a tiny chemical imbalance in the brain for it to be completely out of whack. So that's the other side of the coin. So sometimes I think, yeah, it should be able to do that. Then I think about the brain thinking, yeah, but it doesn't take much to upset it completely. So you might be right, but then again, you might not, because we just don't know enough yet. That's the thing. But it certainly won't hurt to try.
Yeah, like, I mean, I'm sure I'll try it and be like, hey, never mind, we need to figure out NAL 7.
Yeah, and I know I've been there, right? And I was kind of very, so I've been working on this for 15 years now. So I was kind of really impatient, probably for the first 10 years. I wanted it all to work, and I was getting very frustrated when it never did.
Right.
But I've kind of learned over that time period that actually there's so much in the detail and the foundation and everything else that I'm kind of having to be patient, and it's the only way that makes sense to me now, because I've learned that the hard way, that trying to do it any other way was just counterproductive. If I spent the 15 years I spent taking a very methodical, stepwise approach, rigorous testing along the way, I probably would have finished 5 years ago. But because I was frustrated, I wanted it to work. I kept taking shortcuts, trying to move on to the next stage when I hadn't really got the previous stage completely sorted out. Working on the same sort of principle you are. Well, it's good enough. I'm sure it'll be able to figure it out. I've had so many, dead ends and false starts and all sorts of things that I've spent a lot of time. It's not wasted because it's all learning experience, but it wasn't as productive as it could have been.
Right. So a decade to Zen mastery. Got it.
Yeah.
It sounds like I'm gonna have to temper a lot of my expectations a lot. Not that that's a bad thing.
No. I mean, there's nothing wrong with it. Passion and enthusiasm. I think that's great. Yeah. I mean, I guess I'm trying to avoid. I don't want you to become frustrated when it doesn't do what you want,
right.
And then you kind of chuck it in, because I know you kind of been there and been frustrated already once with this program. So I'm just trying to avoid that happening again, because I think you're a good asset to have on the team.
Right. Thanks. Yeah. No, I don't think I'll get frustrated, but it'd be nice. Yeah, it'd be nice to probably switch out the control and just use the sort of. That's what I'll probably end up doing. Switching out the control for a very practical task that I'm working towards.
Okay.
But take away.
A project that I think both of you might be interested in, I know Patrick's mentioned it before, that you can definitely contribute to without any problem at all. Patrick, do you remember after you did the meta rule language, we had a brief discussion about, we thought we could actually do a DSL for NAS in general.
Oh, mm-hmm.
So I've been thinking about that quite a lot since then. And I think there are three parts to this. There's the meta rules themselves, which is its own DSL. There's another part which I'll call the NARDB, and you've seen it's been mentioned a couple of times on the chat recently. I've started to specify a DSL for a NARDB.
Okay, that sounds interesting.
And I think,
can you explain that a little more?
Well, basically, it's the storage system for NAS, but it's a database for NAS, but obviously it's based on concepts and tasks and the storage for those. But what I'm trying to do is separate control, inference, and storage into three completely disconnected components, so they can actually become self-contained libraries or services.
Okay.
And then you glue the whole thing together with a meta DSL for the whole system. It may be possible that you can do the whole thing in a single language at some point, but I'm trying to keep them separate for now for ease of thinking purposes.
Do you have any chicken scratches of this that I could look at?
Yeah. Well, I've got stuff written down in notebooks at the moment. I said earlier on chat that I might be able to get a copy of the NASDB DSL online. I don't know if I'm going to get it done today now because I've been on here for a while now. Right. But essentially, it's kind of just like a mini, anything like Cassandra or MongoDB or any of these languages, but a very cut down version of that. So there's just like a create system concept, and there's create concept idea, then there's an update concept, just as keywords as a language. With that, and you don't actually need that many for a NASDB. It's actually, as a language, it's very limited because you don't need to do much. And the actual database itself, go on.
No, I was just wondering, is there overlap with XJRN? Because I know he's interested in some kind of database type deal.
Yeah, he's definitely a database person, and he may well have comments, but apparently he left today, or didn't. I'm not entirely sure. He does seem to have gone.
I thought he just left for the day.
I think that was it. I think that was him throwing the towel in. Because he got kicked off of Ben's project previously,
Right.
And the thought of him being involved with Ben again, I think, was too much for him.
Yeah. Okay.
Although I think it was kind of premature thinking personally, seeing as it was just a proposal sent to pay. And anyway, that was
it's an emotional reaction. He'll be better.
Yeah. Well, maybe we'll see. Yeah. Well, but to be honest, I can't understand more than 2% of anything he says anyway. So. It's kind of really hard to extract any value from him, in all fairness.
Right. Anyway, so back to the NASDB. Yeah.
So back to the NASDB.
Yeah. Whenever you have some time, I'd love to look it over for sure.
Yeah. So that's kind of the easy bit. The harder part is the control system. I'm still.
Sorry.
How you specify that in a DSL, I don't know yet. I've got a few ideas, and if you've got any thoughts, Patrick, be interesting to hear them.
I
mean, have you done anything on it yet, or is it just kind of a thought experiment at the moment?
It was a thought experiment, but I also tried to write down a control-related syntax. But then I saw that, how should I say, because there's a lot of stateful stuff like the bags and the term links and everything. Then I thought, okay, in the end it doesn't look much more nice than an imperative.
Yeah. I don't know quite where the control is going to go yet, so that's kind of interesting. I am trying to completely separate it from what I'm calling the NARDB, so that state is managed outside of the NARDB with the control system, and then it's just put back in again. So NARDB is literally a storage system, and it will provide, persistence and selection and indexing and that sort of stuff, but there'll be no control management within the NARDB itself.
Would the NARDB be a layer? Sorry, let me start that again. Would the NARDB be a layer over an existing database system, or do you want to create its own database structure underneath?
I've looked at that. There is nothing that fits the requirements of NAS.
Right.
I've looked at MongoDB. I've looked at Cassandra. I've looked at NoSQL. Sorry, MySQL rather. I've looked at graph databases. It's such a unique requirement. The ability to non-deterministically select items it's a real bugger, because there are no algorithms that work for it other than the one we've got. It's just such a unique requirement. There's just nothing like it.
No, exactly. That's what attracts us to this project, right?
Yeah, absolutely. Of course. I mean, it's because it's it breaks all the rules, or it makes its own rules. Yeah. Yeah. So the problem is that you need to be able to access everything by index, or some way at least to be able to non-deterministically select, and that lets out pretty much every database, to be honest, because they don't give you access to kind of like row numbers, because they're not guaranteed to be consistent. So that's kind of a bit of an issue, really. So you're going to have to hand code it basically. But I don't think that's a problem, because it's not a hard storage issue. I've written more permutations of bags than I care to think about, so that's not a problem. It was more about playing with the system in a way that makes it easy to change stuff and try things, and have other people be able to work with it as well. I think that's probably part of my big thing. Like with the meta rule file now, whilst you still need to understand the rules, now they're all there. Once you can read them, you can understand the entire inference rule system for NARS in one place. Whereas before, the only way of doing that was to take 4 books, 12 research papers, and 3 versions of the NARS code and try and figure it out. But now it's all possible because they're all written down in one place in an easy to digest format. And I want to try and do the same thing with the storage and the same thing with the control system.
Right. Yeah, that'd be fantastic.
Patrick,
you
did you
basically
say
just
you
did the whole thing in Prolog?
Yeah, unfortunately, Prolog is not up to scratch for the control system, or we would have done that many years ago.
Definitely, yeah. So you're asking Patrick something?
Yeah, sorry. You said that you wrote down some ideas for the control system a while back. Is that something you can share online with us now, or do you kind of not know where that is?
Oh, control how it looked like.
Do you have the documents?
Oh no, only can reconstruct it.
Oh, okay, all right. Well, that'd be a useful exercise.
It was like something like this. It was a bit like a database language, but let's see. What do I want? Oh. This line there, I was not sure if ROM is maybe the right word, but I wanted to keep the syntax minimal. Then it was just how did I? It was describing everything from the selections, where the selections are coming from, what are they are referring to, I mean, and then it had actor-like patterns to for example, say on boot. How did I realize this? Something like this. So it's how should I say? I'm not sure if it's better than, for example, having public void inference.
Yeah, it's better already because you haven't got the word public void in it.
Concept. How would it be in current Java? See that's same.
Void's back.
Let's put it back. Just for comparison. So it's, how should I say? Out of this language looks simpler. The background assumptions would have somehow to be put into. So the gain is not that much. We could, for example, this one would already be possible with the current code base. And it's just, I wasn't able to get a real gain by this.
Okay, I understand. You're thinking like a programmer still, aren't you? It's hard not to. Let me give you an example of how I would intend this to work. So if you could put it at the top for me, if you could, in uppercase, at the top of your file, if you could type use concept, new line, tab in, inference, new line, then the next bit is just a placeholder. But if you do, for now, write update states. No, you don't tab in again. Sorry, only one tab. Right, that's it. So the use concept, because it's tabbed in, basically it's like a use statement in. I don't know if it's the same in Java, but in C#, for example, it's a scope statement that will automatically free it up when that scope finishes. So it's kind of like a local lock. So when you use the concept, if you don't specify a name for the concept, it extracts one non-deterministically. Then that context is applied to everything below it in scope. So that just does inference on that concept. Then it updates that state. And then at the end of that scope, when the use statement now finishes, so the scope of the users finishes, it now returns that concept with the update state back to the data store.
But it doesn't give much control over where this should be stored, for example.
About what?
For example, what if I want to specify where the result of inference is stored in?
Well, why do I need to store it? I just want to put a concept. You mean the result of inference?
Mm-hmm. Well,
you just want to put it into the storage.
What is if I want to use it in a perception buffer or in a, how should I say, in a different control model, which is different from the default one?
Well, then you can name it then, and that's what I'm saying. If you don't use a name, it will just apply one automatically. If you use a name, then you can use that name in the scope. So if you say use concept and give it a name, then you can use that name as a variable reference inside the scope.
Yes, this I understand, but it would be similar.
No, but you just say you just assign it to the inference. So the name becomes equal to inference, and then you've got the result of it.
But this, I mean, if this one, if this one would already, for example, have a hidden state which tells inference that this is the context or this is the concept it should use.
Yeah.
Then this is like a hidden global variable here.
Yeah.
But the gain, there's not much gain whether it's written this way or this way. Because in the end you would implement this manually in the programming language.
Oh sure, I know, but the idea is it's an easy to I mean I can implement that directly in F# as a language feature anyway, so it's still code. It's not that different, as you say, to your statement underneath. Obviously the update state piece needs to be more complex than that because we have to be able to do various things to control. But I'm not sure I understand your point about what else you need to do in there, which is why I'm kind of I'm sure you're right, which is why I want to test it.
This one, for example, gives a lot of control, like.
Well, that's exactly the same thing. That's why I'm confused. Oh, I see. Because you think you can put the result somewhere else, right? Well, because you can't put the result somewhere else.
Right.
Well, I don't understand why you would put the result in the buffer, though.
I agree, but it gives a lot of flexibility to define.
Oh, okay, right.
Arbitrary contour.
Because I think most of what we're doing with the code is extracting concepts, taking links out, taking more concepts out, taking beliefs out, getting them in the right format, sending them to the inference. It's just all boilerplate. There's no value in that other than it's just a load of steps you have to go through every time. And it isn't going to change because you have to do that every time to get to the point of being able to do inference. Obviously you still have to do local inference at some point as well, which is a different issue. But I'm trying to avoid falling into the hole that Seth created for himself, which is the infinitely flexible NAS implementation. I would much rather have the concise, highly focused implementation that is very short and very easy to understand and does a very specific thing. I know there has to be a degree of flexibility because it's a research environment, but I think it's relatively easy to change a small, concise thing than it is to build a incredibly flexible thing in the first place.
I agree.
So I'm kind of more in line of the simple, concise approach rather than the the flexible but complex approach.
Mm-hmm. But most relevant control aspects, like that the task links are strengthened by derived tasks.
Yeah, well, I don't use those, you see, so it's not an issue for me. It's only a problem for you.
Mm-hmm.
I just use bags, so I don't have an issue with any of those link problems.
Mm-hmm. Oh. Okay.
But I mean, that's what update state is. Update state is change the priorities of the relevant components, whatever they may be. I mean, you can obviously change those relevant components based on your particular model.
Mm-hmm.
But I as I say, go on.
Like looking at this, this text file, and if that's kind of what it looks like, I feel like it's a very slippery slope to just creating an entirely new programming language.
Well, it is a new programming language,
right? But then, like, it's kind of like I feel like you're doing a lot of work for something that might end up being something that already exists, more or less. And then at that point, I'm not sure.
Oh, I see what you mean. Okay,
the value.
But for me, it's actually a really easy thing because it's an embedded DSL. So I can implement this directly in F#. I don't need to create parsers or anything for this. I can just write this directly as F# code.
Like,
probably can in Clojure as well.
Yeah. So
okay. So yeah, I don't want to reinvent anything or make anything more difficult. In a way, I guess it's kind of a simplistic interface, but it's a functional interface as opposed to a programming interface.
Hard and fast decisions on it. But I'm just saying it can be a very slippery slope to the point where it's okay, like in F# or like Clojure, because then you sorry, I disconnected. But
okay. But I think the key thing, I've actually
gives you kind of the benefits of both worlds.
Sorry, we keep losing you there, Jared.
And would simplify a lot of the code, and I think that's probably the best.
We missed the beginning of that because you disappeared.
Yeah, sorry. Like basically, if it's an embedded DSL, like I see a lot of value in it because you have the flexibility of the host language at any time. And that way you're also cleaning up the code base as well, which I can see a lot of value in. And I think that's what you're planning to achieve.
Yeah.
Yeah, that'd be cool. As a standalone language, though, I think that's going to end up being there's a potential for it to be a slippery slope into the point where its usefulness might outweigh its ability to be maintained.
Yeah, I agree. I don't think we're at a stage yet where we can build a hard language in the sense that I don't mean hard and difficult, but like a fixed language, because we don't know enough about the requirements yet. So it does need to be able to be easily changed. Yeah, no, I agree with that completely. I think maybe the database side is a bit different because that interface has been consistent for a long time now. I don't think that is an issue, but the control side is going to change a lot, and it keeps changing, and it has always done, and I don't anticipate it not changing for quite some time.
Yeah, I'd love to see the ideas that you have for that. It sounds really interesting.
Okay, I will get them converted from Notebook to E format and get something online.
Sounds fantastic, and I shall temper my expectations and become a Zen monk for the next 20 years.
Hey, no, I'm not suggesting that.
Yeah. Cool.
Okay,
well, thank
guys.
you very much, guys.
Are we done?
I learned a lot tonight. Yeah, we're done.
Okay, great.
Oh, okay.
Cool. Have a good night.
Thanks,
You too.
Patrick.
Thank you too.
Yeah, thanks, Patrick.
Bye.
Ciao.
Bye.